Hi students and friends, welcome to the channel Learn and Teach by Ayaz. This will be the last video for the topic ion and ionic bonds. First two videos were published back on 6th December 2021. The SLOs for this video are: describe the giant lattice structure of ionic compounds as a regular arrangement of alternating positive and negative ions. State that an ionic compound is a strong electrostatic attraction between oppositely charged ions. Describe, describe and explain in terms of structure and bonding the properties of ionic compounds: high melting points and boiling points, good electrical conductivity when aqueous or molten, and poor when solid. So here's the summary of the last video lesson. Ionic bonding involves the transfer of electrons to achieve full outermost shell inert gas electron configuration. Ionic bonding involves the transfer of electrons from metals to non-metals. When Energy is the combining power of an atom. It helps in predicting the chemical formula between different elements of the periodic table. This is the structure of ionic compound like sodium chloride. Sodium chloride. Here is a formula of sodium chloride. Small red balls represent sodium ions. These are Na plus ions, and the large green balls are representing chloride ions or chlorine ions. Whenever ionic compounds are produced, there are lots of positive and negative ions. Lots of Na positive ions and lots of Cl negative ion. So I'm making the small part of this. You know that positive ions repel positive ions and negative ions repel negative ions. Positive ions repel positive ions. Negative ions repel negative ions. In other words, same charge ions repel each other. At the same time, positive ions are attracted to the negative ions or vice versa. Cl negative ion and positive ion and positive ion and positive ion. It should be Cl negative, Cl negative. And these oppositely charged ions rearranged themselves in the form of giant ionic lattice. This is giant ionic lattice. Giant ionic lattice. If you want, you can draw. We have this like this. So if I am placing sodium ion in the middle, still negative ions surrounding this Na positive ions. like this. In ionic bonding, oppositely charged ions regularly arranged in the form of a giant crystal lattice, which are stable due to strong electrostatic force in the ions. Therefore, high amount of heat or energy needed to overcome break down the strong forces. So these will be strong electrostatic force, which needs to be broken down. What is electrostatic attraction? It is the attraction either between positive and negative ions, positive and negative ions, or between mobile or free electrons and metal cations. Metal cations. What does higher charge mean? For this, you have to consider the ionic compounds Na2O and MgO. Consider two ionic compounds, sodium oxide Na2O and magnesium oxide MgO. You see in Na2O, there are lots of Na positive and O minus 2 ions. And in case of MgO, there are lots of Mg plus 2 and O minus 2 ions, which means MgO has a higher charge than Na2, has higher charge than Na2O. Now, what happens if one of the ionic compounds have higher charge than the other one? Higher charge means stronger electrostatic forces. Higher charge means stronger electrostatic forces, which means large amount of energy of energy is needed to break down the force. This eventually gives such ionic compounds a higher melting and boiling points. Now here are some properties of ionic compounds. Ionic compounds exist in solid state. Ionic compounds have high melting point and boiling points. Ionic compounds are soluble in water. Ionic compounds does not dissolve in organic solvents. Ionic compounds only conduct electricity in molten state or when dissolved in water and aqueous. Now, why ionic compounds exist in solid state, or why ionic compounds have high melting points and boiling points? It's due to many ionic bonds of strong electrostatic forces between the ions. Many ionic bonds compounds or strong electrostatic forces between the ions or giant structure. Therefore, need a lot of energy. Need a lot of energy to break bonds. Comparing the melting points of two different ionic compounds. Let's compare melting points of two different ionic compounds like sodium oxide, Na2O. The melting point is 1132 degrees centigrade. On the other hand, melting point like magnesium oxide, MgO, has melting point of 2852 degrees centigrade. You see the difference in the formula of both sodium oxide and magnesium oxide. I've already explained Na2 for sodium oxide and GO for magnesium oxide. There are a lot of Na positive and O minus ions in case of Na2O, in case of MgO, Mg plus 2, O minus 2 ions, which means MgO has higher charge than Na2O. Higher charge means stronger electrostatic force, means stronger electrostatic force, and hence high amount of energy is required to break the force. Hence high amount of energy is required to break down the force. Now, ionic compounds only conduct electricity in molten state or when dissolved in water or in aqueous. It's due to the reason that in molten state, when ionic salts are heated or when dissolved in water, the ions become free or mobile. Ions become free or mobile. Ionic compounds does not conduct electricity in solid state. In solid state, ions are immobile or not free. Ions are immobile or not free. So here's a summary of today's lesson. In ionic bonding, oppositely charged ions are arranged regularly in the form of a giant crystal lattice, which are stable due to strong electrostatic forces between the ions. Therefore, high amount of heat energy needed to overcome breakdown the strong force. Higher charges mean stronger electrostatic forces. Large amount of energy is needed to break down the forces. Ionic compounds usually exist in solid state with high melting points and boiling points. It's due to many ionic bonds or strong electrostatic forces between the ions, giant structure, therefore need a lot of energy to break bonds. In ionic compounds are soluble in water but insoluble in organic solvents. Ionic compounds conducts electricity only when molten or in aqueous solutions. This is because ions are mobile. In solid state, ions are not free to move. Thanks for watching. Press like and share my video. For more videos, subscribe the channel and press the bell icon.